I am here on the porch of this historic Detroit mansion. Built in 1882 in the heart of the infamous Cass Corridor District, this mansion has one problem that plagues a lot of houses today. Since it's built out of all brick, the Wi-Fi propagation is really terrible. So the owners of this place have asked me if I can step in and help a bit. So today, I'm setting up an all-new centrally managed Wi-Fi network for this 5,800 square foot historic house. So if you'd like to come along for the network transformation of this beauty, or you're designing a home network for a beauty of your own, then come along on this adventure. So first off, here's a quick look at the line of equipment I'm using today. I'm using TP-Link's Omada centrally managed system. So I've got 6 wireless access points, a PoE switch, and a router. And all of these things are managed together in a nice single pane of glass. All of this was kindly provided by TP-Link for the Wayne Engineering Society, a nonprofit which helps Wayne State University engineering students. They're also the owners of this house, by the way. All of the residents here are engineering students, and they're going to help me with the installation today. So I guess the first step here is to figure out what's already in this house. Obviously, a house of this age has had several networks in its past. The most recent one, they've got this spaceship here, sort of tucked up into the ceiling. They've got gigabit symmetrical fiber, which is excellent. But yeah, we've also got this mess going on here, hooked up to some of the different TVs and game consoles around the house. At one point in the last 20 years, a squirrel has eaten some of these Cat 5s here. So I guess I got my work cut out for me, right? Got to trace down, terminate all these wires. I'm using a tool called the POC Ethernet for this. It's one of my favorites. Maybe I'll show you some clips of how that works later, but yeah, let's get on with it. So now that I've taken down that old spaceship from the ceiling, I'm here with the president of the Wayne Engineering Society to take a look at the new gear we've got for the Wi-Fi network in this house. So first off here, I've got Omada Gigabit Gateway. This is one of their more basic gateways, but again, we only have gigabit internet. So you've got the ER7206, a number of different WAN ports, LAN ports. I can hook up all kinds of networks from this. This will be the core of our network. Just taking a look in the box, I got some instructions. Don't need those. Got rack mount ears, power brick, and the unit itself. So here I've got 6 gigabit Ethernet ports, 1 SFP gigabit. Any of these can be WAN or LAN. This one defaults to WAN, and the rest of them can do really anything. So I've made some progress here on the wiring. Still not done yet, but it's time to set up my gateway and my switch. So one of the reasons I like TP-Link is because they have so many options for different types of central control. So in my own house, the one in the US, not the one in Finland, I've used TP-Link's self-hosted controller, hosted on my own infrastructure on Proxmox, to manage my access points. That works great. That's cloud-free, so I can do it all locally, have a single pane of glass for all my TP-Link equipment. Excellent. So another option they have is every single device supports local web management. So if you buy just one switch or just one access point, for example, you can set it up through the web UI and you don't even need a controller at all. So the third option for control of these guys is to buy a hardware controller that basically just runs a self-hosted controller on their hardware that you buy. And the fourth option is a cloud-hosted controller hosted by TP-Link. So they offer this for free for small setups. This is a small setup, and that's what I'm going to use today. Now, if you follow my channel for a long time, you know that I'm really not into cloud-managed stuff. I like to self-control all of my data. However, this is not my house. I have to hand this project over to the owners of this building, the Wayne Engineering Society. And you met Joe earlier. He's going to have to manage this system. He's a mechanical engineer, so he might not be best at running a self-hosted controller in a virtual machine in Proxmox, for example. So he's going to use the cloud-hosted controller, and that's what I'm using today for this setup. So just so you're aware, I personally would prefer to use a self-hosted controller for protection of my data. For other people that may not be as technically inclined, the cloud option is a great option for them. So to get started with this guy, I just have to plug him into power and plug him into the internet, my fiber OLT there. And he's got a QR code on the bottom that has like a device ID. Once I get that device ID, I can go down to the TP-Link Cloud and enroll this guy in my network. from here without actually plugging a laptop into it. So you could come into this building, plug in every access point, take a picture of all the QR codes and then leave, and go back to the office, set up the whole network from there. So I'm basically going to do that, except instead of the office, I'm in the dining room table down there. But yeah, let's get this thing set up. I also don't think I mentioned what switch I'm using either. This is the TP-Link Omada ES220 GMP. So it's a 20 port switch. 16 ports are PoE. They're PoE plus actually, gigabit. I got 2 extra non-PoE gigabit and 2 extra SFP gigabit. So in this house, my only way to run Ethernet to the basement is via a conduit with line voltage wiring. So the only way for me to run there is with fiber. So I've got these fiber ports for the future. Currently though, everything is just up here on the second floor ceiling. So I'll plug everything in here. I can plug my router in one of the non-PoE ports. And yeah, we'll get this guy adopted and ready to go. So for the actual access points today, I've got 3 different models here from TP-Link. This one, the EAP772. This one, the EAP723, and this one is the EAP725 wall.
So what's the deal with the BE11000?
So glad you asked. So BE11000, a lot of people think that's a model number, but actually that defines what standard it follows. So in 802.11, they letter all their standards. So we had G, N, AC, AX, and now BE. So this follows BE standard, the most recent Wi-Fi 7, and 11,000 is the bandwidth. So it's how much bandwidth that all of the radios in this thing can handle together. So this has a 6 gigahertz radio, a 5 gigahertz radio, and a 2.4 gigahertz radio. And those together add up to 11,000. Now this guy here may seem like he's much worse because he's only 5,000. But the difference is he doesn't have a 6 gigahertz radio. He only has 5 and 2.4. So the 5 and 2.4 gigahertz radios on this guy can handle the same amount of bandwidth as this guy. This guy's just lacking the 6 gigahertz third radio. So just because this doesn't say 11,000 doesn't mean it won't work well for you. In this case, we only have 1 gigabit internet. Now gigabit internet is perfectly fine for this dozen people that live in this house, as long as we're not fighting over Wi-Fi airwaves, that kind of thing. So if we have a lot of radios spread around the house, you won't be doing long distance connections through a lot of walls, etc. And the bandwidth will be perfectly fine. Now if you're the kind of person that likes 2.5 gig internet, 10 gig internet, that wild stuff, then maybe looking at 6 gigahertz would be good for you. If you're a business as well with really high client density, like 50 to 100 clients per access point, then you might need something like the 11,000, just because all of the overhead from all of the clients will add up to eating a lot of your bandwidth. Make sense?
Yeah.
So this one's actually one of my favorite form factors here, the wall plate form factor. So this is a BE5000 Wi-Fi 7, but it's a wall plate. So I open the box here, pull it out. You got instructions, throw those away. Here is the beauty. So this guy screws on to an existing wall plate. So your existing Ethernet line plugs into the back here, and this mounts flush on the wall. You get Wi-Fi out the front, and you get 3 more gigabit out the bottom. So these 2 are both gigabit out. This one is 2.5 gig Ethernet plus PoE coming out from our 2.5 gig PoE coming in, and our BE5000 radio inside. Very convenient for like bedrooms or things like that. So Joe here already has an Ethernet line to his bedroom. What do you got plugged in there?
Xbox One.
So he's got an Xbox One. So we don't want to unplug his Xbox One, but if we put this in his room, he can plug his Xbox One in here and get Wi-Fi. Sick. So here's the access point I got. It's got 2.5 gig PoE in on the back, 2.5 gig PoE out, and dual 1 gig. And to install it, I just pop the faceplate off, snap down real easy. They got 4 mounting holes here to fit a variety of electrical boxes. So really just got to put it here, get the screws in. And so this currently has a female RJ45. I could leave this here tucked into the wall and just use a short cable, or I could cut this off and crimp a male on. Either way, I'm basically just screwing this on the box, seeing how it looks. So this is really a perfect form factor for this case in a bedroom here. If you're putting a lot of access points in bedrooms, studies, things like that, this is a form factor you really should consider for residential applications. I know everyone likes the big UFO, but this is a lot more discreet and you get some ports for the room to use. So this unit, EAP723, this is a really versatile all-around Wi-Fi 7 BE5000 ceiling mount access point. Holding this guy in my hand, it's pretty small. I don't know how many inches that is. Maybe I'll put it on screen. Pretty simple thing here. We've got Ethernet with PoE in. If you must power it, you have a 12-volt jack, but we're going to use PoE today. They come with a bracket. You screw the bracket on the ceiling, pop this guy up there, good to go. So I heard you guys had a gaming room. What do you got going on up there?
2 different TVs and sometimes even 3 Xboxes.
3 Xboxes, wow. That's a lot of stuff with Wi-Fi. So this access point is going to go in the gaming room, and it's going to cover all the kind of stuff that they could bring up there if they need to. So I'm up here in the game room with the EAP723 to mention a little bit about how many access points and where I'm going to put them in this house. So if you have a smaller house, it's like 800 square feet, 80 square meters, 1 access point is probably fine. When you get bigger than that, some people start going to like more antennas, more better. What if I have a spaceship with 8 antennas instead of 3? And that's the wrong approach. So now on the flip side, if you have, say, hotel rooms or studio apartments, then maybe you want to have 1 in every single room. In that kind of scenario too, where you have long hallways, you want to make sure the access points are actually in the rooms and not the hallways, because you can get really good signal strength from a whole bunch of APs interfering with each other. While in the rooms where you're actually going through 2 or 3 walls, the signal is much worse. So putting them in, say, alternating rooms or every room, you won't have visibility to a whole bunch of access points at one time. In my case, what I've done in this unit with like 10 bedrooms is I've tried to make sure that I'm not going through more than 1 wall or 1 floor, but not both. So in this case, I have this unit here. This will cover the room directly below me and directly to the north of me. I'll have an access point on the opposite corner that will cover 2 rooms on either side of it and below it. And then on the floor below it, I'm putting them on diagonals. So underneath the room on the opposite side will cover the room above it, etc. So I guess I just got to crimp this thing and get on with it. Orange and white orange, green and white blue, blue and white green, brown and white brown. Got it. Looks okay. Not too bad. So this guy here, EAP772 BE11000, this is like the flagship, Wi-Fi 7. So this guy is quite large here. He's about the size of a dinner plate. Flip it over on the back. You've got 12 volt DC if you must, but we're going to be using the 2.5 gig PoE in. So 2.5 gig Ethernet obviously is quite popular nowadays. With 3 radios in this, this could definitely make use of the 2.5 gig connectivity. Now for this house specifically, we have gigabit symmetric fiber, and essentially all of the traffic on our network is going out to the internet. We don't have any servers, we got no media local, we're not like a business with our local stuff we're accessing, so this Wi-Fi access point would absolutely be overkill. The ones I showed earlier, the BE5000, those would be perfect for this house with this internet connection. However, if you do have 2.5 gig, 10 gig internet, then you could make use of these. Another really common use case for needing such a high bandwidth access point is if you have access to a lot of servers locally on the premises. If you're a small or medium business, you're doing a lot of file copying across your network, but it's not going out to the internet, then you could potentially be sending a lot of bandwidth across your Wi-Fi. Now this one is going to go in that room there. What are you guys doing there?
A lot of get-togethers.
Get-togethers. They get together. And when people get together, they got a lot of phones. They want to show stuff off on TikTok, etc. They're going to need to handle a lot of clients. And so this access point is going to be perfect for them. Also, pro tip, leave yourself plenty of slack. You can always just push it through the hole. Future you will thank yourself. This is the room where they have gatherings, I guess you call them. Not parties, because they're not allowed to have parties. But yeah, so we're putting the big access point here. This guy has Wi-Fi 7. Wi-Fi 7 doesn't actually tell us what bands it supports. So Wi-Fi 7 could be better than 6E or could be worse than 6E, but it's probably better than Wi-Fi 6. So this particular unit's a tri-band. We'll have 6 gigahertz around these rooms on the first floor where parties will be. Mostly in this case it's for client density, not so much for high bandwidth. Again, we only have gigabit internet. Only gigabit's perfectly fine for a house of this many people. But Yeah, I got the big one, so might as well use it, right? If you're designing a thing for your house this size, you definitely don't need 6 gigahertz unless you have a ton of neighbors. But if you have a house this size, you probably don't have that many neighbors, right? Am I right? TIA 568B. Can't forget it. Then we trim the ends off. Get another cable from the little baggie. Okay, so I'm back here to set the whole system up in the Omada Cloud. It's already set up, but I'm going to walk you through what the Omada Cloud looks like so we can enjoy it together. Now the setup did go really smoothly, except that I made one mistake and my ISP caused me some trouble. So the first mistake I made is I installed all the access points on the ceiling, then I threw away all the boxes. So they're in the trash, they're bagged. Then I realized that to add these guys to the cloud, when it's not like locally hosted, so it can't auto-discover everything, you need to add them by serial number, which is printed on the box, or by device ID, which is the QR code on the back. Now Omada actually has an app to make this really easy. So if I would have created the cloud organization and site before I even left, I could have scanned all of the boxes before they left for the site, added them to the system, and they would have just magically appeared once they had an internet connection. So you can send out a team of installers if you're an MSP, scan all the QR codes in sight, or scan the device keys on the Omada app on your phone as you're installing the AP. They'll pop up right away, super simple. I did that for like the last AP, and I was very happy with it. The other problem I had is the internet. So what's supposed to happen is, by default, there's 6 Ethernet ports, one of them is SFP on the gateway. Out of the box, they configure the SFP and the first gigabit or first RJ45 port as WAN. So you plug either or both of them into your internet connection. They're both configured for DHCP, they should come right up. If your ISP does DHCP properly, it'll connect to the internet, get an internet IP address, reach out to the cloud, and if you've added it by device ID, or device key, and not by serial number, it'll enroll itself in the cloud automatically. Gateways are a little bit special in enrolling because they have some additional security implications. The problem I had is my ISP is stupid and binds the MAC address. So when it came up, it couldn't connect to the cloud, it couldn't get a DHCP address, so I had to actually plug my laptop into the router and clone the MAC address from the old router. Now this isn't hard, this is something that happens with bad ISPs all the time, but it was just kind of a pain for me. Another problem I had was I was planning on testing pretty thoroughly the IPv6 support of Omada. I didn't realize that the small local fiber ISP in Detroit doesn't support IPv6 and doesn't appear to care to, because they were bought by a larger ISP in 2020 who didn't really want their residential customers anyway. They just wanted to sell business fiber circuits and wanted the fiber network they'd built out. So they're kind of limping along this residential side with no changes in the last 5 years. So no IPv6 there. So unfortunately I wasn't able to test the auto config of IPv6. I'll have to do that in a future video. Once I had figured out the ISP foolery, everything just pretty much came up. So I either typed in the serial numbers that I dug out of the trash, or I took the APs down and I scanned the QR code on the back properly. They all added themselves to the system, configured themselves, and the network was up and running in like minutes once I had figured out the stupid ISP problem. So let's take a look at Omada Cloud together. So here we are with the system like as it is. So it shows me I've got the internet, it's plugged into port 2 on the router because port 1 is SFP. That's plugged into port 3 on the router and 18 on the switch here at gigabit 1000 FDX. That's connected out to all these devices. So these are all devices that pass traffic downstream. So I got 5 APs. And in this group is just everything plugged right into the switch. So that's on port 14, port 7, port 2, port 13, port 10, etc. I can click on this to see who's connected to that AP. So I got an iPad, someone's Galaxy Note, some private MAC address device, etc. They're all on 5 gigahertz. This one here probably has some clients on 2.4 and 6. So Justin's S23 Ultra seems to like 6 gigahertz. Lucky him, I guess. These guys are on 5 and 2.4. I can continue to expand these out and see what's hooked up, etc. And looks like we've got one client that's plugged directly into port 9 on the switch. I think that's a desktop. So if I click on something like the streaming switch, I can see it got an IP address. I can see it has a link local v6, but I don't see the global because there's no global here. I can also hit config, and add any specific devices to this specific MAC address. But I'm not going to do that because I don't want to hurt the streaming stick. Now to add devices, I can go here to Devices and hit Add Device, and then add them by serial number or device key. Now if you have the mobile app, by the way, for Omada, and you log into it, you also can use your phone's camera to scan the QR code right on the back of the device, which is even easier than typing it in here in the web UI. Obviously these are all connected and happy, so we don't have to touch that. If I come over to Clients here, I sort by download. I can see some people are downloading a heck of a lot of stuff on their Roku, but now they can stream because they have a good network, right? But I know you guys probably aren't fooled by the fancy bling. You want to see some real settings. So for settings, we've got obviously plenty of settings. The first things I set up were LAN. So I just set a single network 192.168.64.1/20. And if we hop on here, we're using all of the LAN ports except for the one that's used for WAN. I've chosen the DHCP range starting at 69, obviously. And I have plenty of options here for DHCP, DHCP-V6, etc. Now I did find some extra settings boxes enable when you have IPv6 support on any WAN interface. I don't, so those boxes aren't popping up here correctly, but it is showing those boxes when V6 is enabled. I just don't have IPv6 from this ISP at this site. Next up in settings, I made a WLAN. So we can set what bands it's on, we can set if it's doing guest network isolation, we can set if we're going to do security or not. Now this is not set the WPA version, it just sets WPA. Under advanced settings, we can choose WPA version here, and because I've enabled 6 GHz, my only option is enabling WPA 3. We also have the option to enable MLO on Wi-Fi 7, protected management frames, rekey intervals, rate limit profiles. If we want to enable minimum data rates, so we could, for example, disable the legacy rates for 802.11b. That's recommended for pretty much everyone. We have the option to do multicast to unicast, V4 and V6, ARP to unicast, good stuff like that. And the final feature I got for you is the map. So I've set this up already so you don't have to watch me draw out the floor plan, but let's take a look at this. So I got a map here. For the first floor, I did one for the second floor, and I did one for the third floor. I didn't bother with the basement. So here on the first floor, for example, I got brick walls that are thick, I got brick walls that are thin. If I go in edit mode, you can see what that looks like. So in wall mode, so I got an orange brick wall, which is 4 dB. So that's like this guy here is an interior brick wall. This guy around the outside, those are exterior brick walls. Probably should add some of those guys where the fireplaces are, because the fireplaces are like hella brick. Brick. And like this guy here too, he's like extra brick. So then I can go here to wireless devices. Actually, they've already all been added, so I'll delete this guy from the map. So here's all the devices that aren't on the map. So I can just say he's right here. There he is. Done. Simulate. And now this is predicting my wireless signal on the first floor from all the APs on this floor. In 2.4, I can do it again for 5. So 5 is not so good because of this fireplace here, but I mean, what are you going to do about a fireplace that's a foot thick? And 6 GHz, similarly, not awful, at least in the party room. Now if I go up to the second floor's got less brick, so we can simulate that at 5 GHz. So I've got 2 APs here, in this room, and then down in this back hallway. So this will get great coverage in the back hallway, which had none at all before. If I go up to the third floor as well, I've got 2 APs here. And the third floor is all wood, so coverage is honestly pretty great. Now the one thing this can't simulate is vertical. So it's simulating the horizontal spread through the walls, through the surfaces, etc. It's not simulating the vertical propagation through floors. So because I have staggered my APs diagonally, not so they're on top of each other, etc., I should get some signal from the APs above and below as well. Now, obviously there's a lot more propagation loss through like a solid wood floor than there is through like a drywall wall. But in this house, where the walls are plaster and lath or brick, the floor might actually be the best option for propagation. So this won't simulate that. If you need to simulate floors, you'll need a better tool. For most houses where the floors are a significantly higher loss than the walls, this will give you a pretty good idea. So like one example where that's important, This is the kitchen back here where it shows I have pretty awful signal. Like I get red here, then I'm going through a thick brick wall here. If I pop up to the second floor though, I've got an access point right here above the kitchen. So it's getting great coverage back here. The thick brick wall is stopping it all, but it's probably going to go through the carpeted floor into the kitchen below, which the simulation isn't showing. And of course here, so if I were to look between the floors, there's another access point right about here, and there's another access point right about here. So this back room that's going through a brick wall again would probably get pretty decent coverage here, even though it's not from this access point. This one's actually got a chimney in the way, so the poor guy in this bedroom is on the other side of a foot-thick brick chimney, but it is what it is. And now, with the cloud service, with the free license I'm not using the paid license, you can also simulate what it would be like to add more APs. So before you've even added any APs, you can go in here and start adding fake APs, and then later, as you actually install them, replace them with the real ones. So for example, on this first floor here, we'll erase the simulation so we can edit. I'm going to add a virtual device. What devices we like? We want an EAP and maybe just a real basic guy. So like an EAP 723. Search for that. And I want the US version, and I'm thinking about putting him maybe right here. Maybe right here, maybe right here. What do you guys think? Let's try right there. So let's see how this looks. So if we simulate this on 5 gigahertz, now we're doing great. Now if I edit him again, I'll lose the simulation. What if I move him over here? How would that look? I mean, either way, our parties are going to be perfectly fine. I could again move him out to the kitchen. I have the ability to run down to the kitchen. Then the kitchen would look great, but again, I think that's an artifact of the traveling through floors thing. So then when I get the real one, I can come over here, edit, add my adopted device, and then delete the virtual one. Click the virtual one, remove from map, etc. So it's been about a week now since I set up all the Wi-Fi in the house, and I'm here to ask Joe how it's been. So Joe, how was the Wi-Fi experience? I know it was pretty bad in your room before.
Yeah, previously I was getting about like 50 megabytes per second. It's now an increased tenfold. I'm getting like half a gig. So that's been really great.
So were there any like dead spots before, or has that been fixed?
Yeah, I don't know if there was full dead spots, but definitely areas that got worse coverage than others. For example, the basement was kind of rough. But I haven't done any internet tests, but we were streaming a movie last night and it seems no lag, no buffering, so
Oh, that's good. I was worried
pretty good.
about adding another access point to the basement, but that's working well, then I'm really glad to hear that.
Mhm.
How about the game room? How are the 3 Xboxes doing?
Oh yeah, they're doing pretty well.
And have you guys had a get-together yet to test the Wi-Fi in the get-together room?
Not as of yet,
Okay, so I guess
but
that'll
we'll
be a
see.
later test.
Mhm.
So everyone, I'm going to say goodbye to Joe. I'll do my little outro here. So if you guys want to chat with me, Appleart, I have a link to my Discord server down below for that. If you guys want to give me a tip, I have a Ko-fi. It's kind of like Patreon, but it's a one-time thing. We can all thank Joe for letting me work at the Wayne Engineering Society house and being able to help them, along with TP-Link for providing the equipment in this video. If you want to buy any of it, I have links down below for the TP-Link equipment. And as always, I'll see you guys on the next adventure. So, goodbye, guys.